What we see with investors, when we look at performance, the margin for error has been greatly reduced. Nowadays, the margin for error is much smaller. We're currently working on a multi-gigawatt project for a client in the Emirates, and I was running the numbers on that. If they lose 1% in performance, it will cost them $1.4 million per year, which is over 40 million over the lifetime of a project.
Hello and welcome to episode 3 of PV Unplugged, where we're talking about the burning issues facing the solar industry today. I'm your host, Jonathan Gifford. This episode is called The Long Haul, Engineering Assets for 25 plus years, which might seem ambitious from time to time, because we know that in PV technology, things evolve very quickly, which means there's always a balance between newer, higher efficiency products and also due diligence and making sure that they will last in the long run. And then, of course, there's the ever-present pressure on cost. My co-host today is Dominic Bürgi, the head of services at Stäubli. Now, Dominic, you just recently spent a few years in the US for Stäubli. You're now heading up the services offering that Stäubli is bringing to the market. Can, first of all, you just tell me a little bit about that? Give me an update. How are things going as you introduce that to the marketplace?
Sure, thank you. Happy to do so. So with Stäubli, we are in its heritage, a product manufacturer, and we decided to offer adjacent services along our product portfolio. And we built up a team and an offering in the US and now rolling it out on a global scale. So very excited about that, and I'm really happy to lead the team and tackle that challenge.
Okay, well, services is very much involved in delivering quality or trying to foster durability in PV products, and that's very much the focus of our discussion. And our guests this episode are Joerg Althaus, the Director of Engineering and Quality Assurance Services at Clean Energy Associates, and Madeleine Hill, a partner at Everoze. Joerg and Madeleine, thanks very much for joining PV Unplugged.
Thanks for having us.
Thank you.
Well, Joerg, while we're talking quality, let's kick things off. At CEA, you're very much at the coalface, at the front line, seeing what kind of failures are manifesting themselves in your testing and also in the field. Can you give us an update? What are we seeing today in the solar market in terms of risks when it comes to durability?
Right, for those who know me, I've been in the quality assurance business for 2 decades and a bit more now. And one astonishing thing to me is that we kind of still see some of the things I have seen early on, which is, for example, issues in the lamination, tiny bubbles forming around the edges of the modules or at the outlets where the junction box is coming. It just requires careful lamination process control. And that has become harder with glass modules that we see these days. So that's one thing I still keep seeing, or we still keep seeing. The other thing is that maintains an issue is soldering. It's the weak point, and it's also the most critical point where the cell strings get connected into the junction box, because you have the full power, the full current, the full voltage. And if a soldering point is not done well, the risk for a thermal event is real. What we see as a result is that bypass diodes or substrings are failing in the field. And finally, a more recent thing is with the move to TOPCon and the issue of TOPCon with dark storage conditioning is that the power measurements in the factories are more challenging and more error prone. And therefore, power verification is something that can be quite off these days.
Right. Joerg, let me jump in. So what do you believe is driving these issues?
Right. I mean, first of all, what we see is that a lot of the suppliers have ramped up factory capacity quite rapidly, at the same time moving to new technologies and putting factories in new regions, new countries. So that ramp up always is a risk for increased quality issues. At the same time, handling new technology. I mean, we've been seeing this in the solar industry for decades, that every time something new comes in, there's also new risks. And that is just something that needs to be carefully looked at and possibly just increase quality control, at least for newer factories, until we have stabilized quality.
Well, you mentioned your new geographies. It's been a feature, not a bug, of the global solar market that we've been pushing into new geographies all the time. But of course, that does bring issues when it comes to the supply chain and ensuring that the PV projects are built to meet the local conditions as well. Madeleine Hill, at Everoze, you work in projects right across the world. Are you seeing different kind of geographical challenges that where developers are perhaps struggling to keep up?
Yes, yeah. Thank you again for having me on this podcast. It's a pleasure to be here with you all. And you're totally right. And not only between different geographies, because sort of within a country there are so much variation, just within regions of specific countries, but also down to a sort of site-specific level. And what we're seeing is that, solar, as you've mentioned, is this expanding market. There's a lot of growth. There are a lot of markets which have seen a sort of astonishing growth, and some which are really starting at the beginning now. And I think it's really critical that as an industry, we take those lessons from those markets that have really they've sort of seen it all in their geographies, in their markets. So talking about countries, particularly in Europe, like Spain, the UK, where we've got sort of like aging fleets of solar, and to really kind of take that knowledge and that learning and translate it into markets which are growing. And like you said, at Everoze, we're working in lots of different markets across Europe. We're even out into Australia. And the joy of the kind of the teams that we have is that we really bring that knowledge kind of from one side to another, so across the technologies and across the markets. And I think that's really what clients are looking for these days. That's what the investors, what the developers want to hear is kind of what's happened over there, and how can we learn about that over here.
Okay, thank you, Madeleine. Dominic.
Yeah, super interesting. Thank you, Madeleine. So how does that, like, maybe to deep dive a bit on that, how does that cross-pollination of like knowledge work in Everoze as a developer? Sounds very interesting. So how do you approach that quality control across the geographies?
Yes, yeah, it's a great question. So just to take myself for an example, I'm working in projects in Germany, in the UK, in Ireland, and I'm based out here in Spain. So I have the luxury of kind of seeing lots of different types of projects, lots of different combinations of technologies. We're seeing large-scale solar and BESS being developed in the UK. We're seeing solar being developed in Ireland, and there's sort of a real big boom sort of happening there. We're seeing sort of lots of rooftop development in Germany, and of course in Spain there's this aging fleet and sites in operation. And each of those types of projects, they give us different lessons. And particularly the kind of lessons that we like to draw upon across the team are really where our clients are seeing sort of similar problems from one project to another. And so we'll often end up having these kind of quality control discussions. We're looking for things like risk mitigation in not only in the procurement side, when we're looking at good quality components, good quality sort of suppliers and procurement processes, but also through to kind of contractual risk mitigation, and then through to the kind of financial model side of things. All of those sort of strategies have been applied in a certain way in, for example, the UK, as projects get developed out, constructed and operated. And we're able to kind of take those things that we're seeing, taking the kind of challenges and problems that we're seeing in some of those projects, and really kind of talk about them in a real sense. It's not just sort of theory on paper, sort of coming out of industry sort of discussions and kind of theoretical conversations. It's really coming out of like project data. And the great thing is that many clients that we work with now, we are seeing that they are also spreading out into different geographies. And I think that it's really important that those lessons are taken with them, because we've already fought those battles once. It's important not to kind of keep pouring the same energy into the same conversations. And I do think that investors, that developers, the whole industry in itself, I think, is learning from that, and is kind of moving forward. But like you said at the beginning, the solar industry is this constant moving, growing kind of beast that presents different challenges, which I'm sure, Joerg, you've been seeing for years now, and even new things that are popping up in the last couple of years. It's something that we want to make sure we're focusing on these new challenges, and we've got the old ones kind of learned and in the bag.
Yeah. And well, if I could jump in, Joerg, one of the things that is a constant is this pressure on cost, and I think it's been even more pronounced in the last kind of 18 months, 2 years or so. How are you seeing that squeeze the supply chain when it comes to durability, quality, reliability of components?
Well, that's the thing. As you said, the cost pressure is immense, no matter where the supplier sits. And the first thing that people do is look for cheaper materials to cut their cost, and also see, where can the process be optimized, use less manpower, maybe reduce the inspection points, and so on. So cost pressure has the ability to put pressure on quality, and that has to be a careful trade-off. And the real risk is when new materials are put into the market before they have been thoroughly gone through enough reliability. And that's what we've kept seeing over the years in solar, that new technology, new materials came into the market, and years later it was found out they were actually not fit for the market.
Well, episode 5 of this series, PV Unplugged, will be Materials Matter. Well, we'll be looking very closely at PV module and system materials. Dominic?
Yeah, I think from a manufacturer's point of view, we also look at that as more like a triangle, right? We have cost efficiency as a driver, but then there's safety and reliability on the other, and we have to balance these areas very well. So I'm kind of curious. Also, Madeleine, on your side, you mentioned we have to respect that learning curve and going through sharing that knowledge and the quality control. How can a manufacturer like Stäubli or CEA across the value chain tie into that?
Yeah, it's a really important point, and I think it comes back to this feedback loop that I mentioned before. That the more we sort of learn and grow as an industry, I think the more kind of feedback loops. This is a very good example here, where we're sort of many people coming from across different points in the industry, and we're really sharing lessons that we've learned. I think that there's this. I think I was listening only last week to a sort of series of sessions on exactly this topic, and I believe that the kind of making sure that loop is kind of closed, and making sure that the quality is really is identified, like that the issues or anything is identified, that it's tracked, and then that those kind of those new measures or those quality measures are then really like followed through and kind of implemented and made sure they're sort of overseen. And I think that manufacturers and even sort of EPCs and different kind of procurement and sort of construction companies, I think, well, even down to ourselves as technical advisors, so long as we are kind of constantly looking back at what went well, what didn't go so well, and how can we implement that going forward, making sure that that's tracked, that it's followed, and that it's checked again in the next sort of iteration going forward. This is really the most sort of efficient and kind of effective way to continue to keep up with these changes in the industry, and to make sure that products but also services are really following these trends that are occurring across that are affecting all of us, really.
Yeah, good point. I like that spirit of continuous improvement and quality control. And maybe moving from the development kind of like phase into more the construction side, Joerg, you mentioned the soldering on the component level. Do you also see some risks on, for example, the installation, or what are the current situation in installation phases, construction sites? What do you come across on your side?
Yeah, so I mean, I mentioned briefly the move to glass modules, and at the same time, the modules have gone much bigger, higher current, but also at the same time, the frames got a little bit thinner. So these very large modules handled in the field and then put on the racking, they have to be installed really more carefully in terms of meeting the installation manuals prescribed torque on the clamps, position of the clamps, and even the compatibility with the racking system. What we see is like the racking manufacturer typically does wind tunnel testing to make sure the racking is good enough for the load of the module. The module supplier likewise tests the module under standard uniform loads as according to the standards. Nobody really tests the combination, and in reality, the load on the modules is not uniform. And so to at least keep your warranty, what we see in the field is sometimes the clamp distance is outside of the specifications, screws are over torqued, and so on. So it's really difficult then to have a claim. What we see in the field is that we have an issue of backside glass breakage that is widespread from multiple suppliers, multiple racking systems involved, and across the globe, really. So that's one of the dominant parts at the moment. At the same time, all things I think Stäubli is very aware of is the cross-mating of connectors and field-wired connections that remain an industry issue.
You mentioned backsheet breakage. Of course, going back in the solar industry, we've had discussions about backsheets for many, many years when it comes to quality, now replaced by this thin kind of semi-tempered glass on the rear side. As my understanding, it could be an interplay of factors, wind loads, as you said, the mounting structure itself, but also things like handling, things like O&M. It really takes a system level approach to kind of avoid some challenges like this, to avoid some failures like this in the future. Madeleine, is that, as an independent engineer, are you looking right across a project like that in terms of how it will also be operated and the O&M schedules that will be put in place?
Yes, absolutely. I mean, from our perspective, we're looking at the project as a whole. So we're not sort of only considering, from a manufacturing perspective, what kind of specs are coming in to the project and what's going to be installed. But we're also looking at that on this kind of long-term scale in terms of how is a project going to be maintained? What sort of challenges will an O&M face? Are they sort of set up to be able to face those challenges? Are the protections kind of in place to make sure that the risk sits with the right party? I think that's one of the key things that I've always got in my head when I'm looking through contractual structures or kind of long-term agreements, is really, is the right party looking after the right piece, and sometimes that doesn't line up. But it's really important from our perspective to kind of look at the project as a whole, and also for it to sort of sit in the context that it's in terms of the kind of site-specific conditions that it will face, because you can kind of have a solid O&M agreement, but if there's no consideration for what's actually happening on site and what kind of sort of conditions could occur, and particularly with the kind of increased climate sort of extreme events, without that sort of consideration, so not just the project in itself but also its context and its location, we're really looking at across all of these things and how they interplay with each other.
Okay. Well, testing is a key part as well, and component suppliers will have their products tested over time. But as you mentioned, Joerg, things are moving fast. It's always an issue in this industry. It's always a kind of standard that new technologies are coming into the market. How is testing keeping pace with the level of technological change?
It's always lagging. I mean, we know that. Now we have this glass breakage phenomenon. And of course, the standardization committee is thinking about how could testing be done differently to avoid such failure. At the same time, TopCon introduction brought UVID. Now, UVID testing has been standardized. It's being adopted, but at the same time, a lot of people still say it's not sufficient. And UVID is still something that needs to be screened for, while it's understood and can be avoided by using more expensive aluminum oxide layers on the cell or what have you. It's still, with the cost pressure, it's something that's still there, and therefore the issue arose. Standardization was lagging and 3 different methods floating around. Now we are years later at a point where maybe we have standardization available. But I think that's an ongoing situation, that new issues arise and the standards need to be developed to screen for those new errors.
And of course, we're discussing standards with Guido Vollberg from the Stäubli team in just a few episodes' time. Dominic?
Yeah, I just wanted to kind of like jump back or circle back to Joerg's comment earlier on the issues of field-made connectors, or the challenges with integrating a connector into a system. And I think that's also where we as a manufacturer tie into this conversation, where we can provide support with trainings and Golden Row events, where I think we collaborate with technical advisors and inspection agencies, where we can share the knowledge and advise on on that very specific niche, how to properly manage the product. Where I think sharing knowledge is something which is of mutual benefit to all of us.
Well, and also during construction, it's not a case of best practice, which I think is not only a case of best practice, which is super important. It's also a case of kind of ongoing monitoring and supervision, because some sites can be absolutely vast. Is that right, Madeleine?
Yes, absolutely. And I think that's probably one of the trends that is quite sort of prominent at the moment, is just how big the projects are getting to. The sort of these sizes, these sort of hundreds of megawatts, to be able to kind of cover and monitor really what's happening in every block of that sort of project. It's a lot of work, and it takes a lot of expertise to kind of a lot of people to get out there and to really see what's going on, and to be able to spot maybe a connector which has been poorly located. It may be the most sort of highest quality connector, but if it's sort of right between 2 modules on where the rain's getting through constantly, it takes somebody who's got a trained eye to be able to see that, and then to be able to think about the impact of that across sort of 100 megawatts. And so I think it's a huge challenge. I've been out on sites that are of this scale, and it's really vast. You think, gosh, how am I going to spot something in all of this? And it's something that has to be certainly considered when we go out and do these kinds of inspections, and to really think about the implications across the entire, of one observation across the entire plant.
Joerg, the challenges of scale. What's your take on this issue?
Yeah, look, I mean, with the pure amount of modules in the field, then it's really hard to spot something that has a low failure rate. And I'm thinking, for example, the soldering in the junction box. It's not something that we see in the factories all the time. The soldering is loose, but you might have one module in 1 million or one module in 100,000 or something that has an issue. Identifying that in the field and taking the right decisions what to do is really hard. But not identifying is a thermal event to happen. So it's just having the right inspection methodology and screening for non-functioning diodes and so on. You have to use the right methods to look at the scale.
Okay. Well, thank you very much for sharing those takeaways, Joerg Althaus from CEA and Madeleine Hill from Everoze. And thank you, Dominic Bürgi, for co-hosting this discussion, episode 3 of PV Unplugged here on the Stäubli podcast. And do stick around because we're going to look a little bit closer at investor expectations, insurance, and expectations also for repowering with the CEO of Sinovoltaics just after this. With their money on the line, it's often investors who pay the price when PV project durability falls short of expectations. But it is also often an underrepresented voice in these durability, reliability, quality discussions. Based in Hong Kong and China, Sinovoltaics has been helping investors de-risk their projects since 2009. And I'm pleased that CEO Dricus de Rooij joins us today on PV Unplugged. Dricus, thanks for joining.
Thanks for having me.
Well, you're based in Hong Kong, and I understand have been for about a decade or so. Why is that location, strategically a good one for yourself and for Sinovoltaics?
Right. Why based out of Hong Kong? Well, first of all, I just enjoy living there. I live there with my family. I have 2 daughters, French wife, and there's just a large international community. And you have a large city, but you also have nature. So it's an enjoyable place to live. But aside from that, it's a city very closely connected with our industry. Hong Kong is quite strategically located. It's part of the GBA. It's the so-called Greater Bay Area, which means it consists of Hong Kong, Macau, and Guangdong province, which is cities like Guangzhou and Shenzhen. And these cities nowadays are all very well connected. What people often compare the GBA area with is you take the financial strength, like a city of New York, which would be Hong Kong, combined with a high level of innovation, place like Silicon Valley, but then in the electronics sector like Shenzhen. And you combine this with the manufacturing powerhouse, which is mainland China. And this is somehow a triangle, and it's all within 30-minute train ride. So it's very fertile ground for a lot of companies in our sector. So you have companies like BYD active not only in the EV space, but of course also in battery energy storage. Companies like Huawei, so inverter company, storage company. You have many inverter manufacturers there, PV manufacturers. And then Hong Kong plays a role as well. You have, for instance, this year we had the largest IPO was CATL, the major battery manufacturer for EVs, which is also playing a very important role in our industry. I think they're one of the leading battery energy storage companies. So they went IPO in Hong Kong. I think next is actually Sungrow. They're planning to go IPO in Hong Kong as well, which is one of those companies that we've seen grow up in Asia. It's one of those companies that kind of made it, right? They're a major inverter manufacturer now, and a battery storage player. And maybe I can share a story about the early days of Sungrow. A company like that we see growing up. I remember being active in the PV industry in 2009. Used to have a client in Belgium who was doing lots of residential installations. His name was Jens. If Jens hears about this story, he's going to have a good laugh. So this was during a time that he was doing PV installations in Belgium. And by the end of the year, the feed-in tariff was coming down, which means they had a very tight deadline to finish many projects. And the problem was they completely run out of inverters. So there was not a single SMA inverter to be found in Europe. And this is when he gave me a call. And he says, Dricus, I need some help. I think I'm being scammed. And I said, okay, well, tell me what's going on. He said, well, we're completely out of inverters. So what I did, I placed quite a big order with this Chinese inverter manufacturer. And they said they could ship immediately. So I paid them 100% up front. And now they're not shipping out. And I need these inverters. And I think I'm being scammed. I said, okay, well, that doesn't sound very good. So what's the reason they're giving? Well, they say it's snowing at the factory and they're not able to ship us those inverters. And I was in Shanghai and it was freezing, but we hadn't seen any snow that year. So I thought that doesn't sound right. I said, okay, leave it with me. I'm going to go have a look. So the same day, I bought a ticket to Gifford, where the factory is based. Oh yeah, and my last question was, what's the factory? He said, well, they're called Sungro. Okay, Sungro. Well, I know that factory. They were already quite significant back then, but not that big. So I take a train to Gifford, to Sungro, and I arrive at the train station. And guess what? There's a half a meter of snow. So they were completely snowed in. So they were actually telling the truth. But he still needed his inverters, right? So what we did, we spoke there with the team, and then the problem was these inverters, they had to go to the port. And they had to go first to a logistical hub, and from there they would load them on much bigger trucks. And the highways that were free of snow, they would clear them. So what we did, we paid a truck driver to take those inverters. We paid him 3 times the price. And we actually drove those inverters to the distribution center, the logistical hub, and from there they were shipped out. And so that's how we got to know Sungro, and it's one of those companies that actually made it. And I think there's quite a lesson in there, because for every company that has grown up, there's maybe 5 or 10 companies or factories that didn't make it, right? And this was the inverter space they were active in. There's many inverter players that at some point were very large players. I think about AeroSharp or Semel Power, and those were companies with a fair market share, but eventually they didn't make it. Right, so I think the lesson in there is to very carefully pick your suppliers, to really qualify the factories you're working with, really know where they stand technology-wise, know where they stand in terms of financial strength, and that really helps to pick the right players.
Yeah, and it's also sometimes good to know a truck driver or two when you're in a pinch. And it certainly wouldn't have been credible if it was a manufacturer in Shenzhen or in that region around Hong Kong. But it is remarkable to hear that they would have been snowed in, is what I'm saying. But it is remarkable to hear about this kind of combination of finance, also the legal profession in Hong Kong, and then this manufacturing hub in power electronics. Dominic?
Yeah, I think that brings us to the point also, like, to investors, like you say, they have to pick their suppliers carefully. So what are they looking for, and you know, how has that changed over time? Very curious about that.
Investors nowadays, they count on a fairly long technical lifetime of a PV project, right? You're looking at 30, 35 plus years. They're counting on. And this is actually something that always keeps amazing me, that what the lifetime of a PV module needs to be in our industry. I mean, Dominic, name me one electronic product outside of our industry that has a warranty for 25 years. I mean,
right. Good point.
Yeah, I don't know of any. I know, like, I mean, I think satellites, they last for 12, 15 years, or even a pacemaker, maybe 12 years. I mean, it has a battery. So PV module technical lifetime is an anomaly. What we see with investors is that when you look at performance, the margin for error has been greatly reduced. Right? In the early days with royal feed-in tariffs, if a plant was underperforming 3% or 5%, it was either built into the forecast or it was kind of brushed off. They would say it's maybe some dust or it's the weather. It's just PV being PV. It happened. Nowadays, the margin for error is much smaller. We're currently working on a multi-gigawatt project for a client in the Emirates, and I was running the numbers on that. If they lose 1% in performance, it will cost them $1.4 million per year, which is over 40 million over the lifetime of a project, which is by all means it's completely unacceptable to lose this kind of money. If they outperform by 1 to 3%, make an additional 120 million. So the margin for error is very small, and it's all about performance. And if you look at our work doing quality assurance at factories, this is our work has completely been transformed in the past let's say 3 years. Let me try to give you an example. So let's say Jonathan, you're developing a PV project. Let's say you're doing a 150 megawatt project and you're buying 300,000 PV modules, right? From a tier one, in fact, in China. Can be anything. Dongwei, Jinko, JA, Trina, any of these tier ones. How a traditional, let's say an old-fashioned inspection company works, until today, they do it like this. They, out of those 300,000 panels, they're going to go to the factory with one or more people, and they will take a sample, right? So out of those 300,000 panels, they might end up testing 3,000, about 1%. And those 3,000, they run their test, and then based on the samples and the quality standard and a certain AQL, the accepted quality level, they're going to decide if each batch is a pass or a fail. Okay. So out of those 3,000, they might find some defects. So they might end up rejecting 50 or 60 pieces. Okay. This is how most inspection companies operate. The problem with that is that you leave thousands of panels untested, and you leave hundreds or thousands of defects inside those modules. So sampling doesn't work in our industry because everybody knows that in the PV plant, modules are connected in series, right? Everyone knows this. So if you have a 150 megawatt project and you have a couple thousand modules in there, defects, it will drag down the performance of the entire plant. So sampling is a thing of the past. What we've developed since 2022 is to bring 100% testing to the factories. So out of those 300,000 panels, we're able to test each and every one of them with a solution called SELMA. It's called Sinovoltaics Electroluminescence Mass Analysis. And what it does is during production, on the fly, we analyze every single module. And if there's defects, those modules are directly replaced. And I can share some data with you. amongst the tier ones, the average rejection rate is anywhere between 0.5 and 2.2%. That means for your 150 megawatt project, you're going to replace anywhere between 1,500 and 6,000 plus modules. And that's a lot of modules. And because they're connected in series, if you wouldn't do 100% testing, you leave these in the plant and they would drag down the entire performance. And if you leave this in the plant, you're basically going to pay in the long run by having underperformance. So this is a major change in the testing space, that we go from sampling to technology-driven inspections and 100% inspections. And it's honestly a must, because it's driven by the market, because there's so little wiggle room anymore when it comes to performance.
But if I understand it right, when you're doing that volume of EL testing, that's huge amounts of data that is coming off the production lines, and that then you use AI to process just this vast volume of data. Correct.
Yeah, it's a machine learning model, and the interesting thing is that the software is being updated on a very regular basis, because technology is changing very quickly. So it needs to be compatible with N-type topcon modules, IBC modules, HJT modules, and so the model has to be trained with a lot of data to achieve the accuracy. And the current model can recognize, analyze up to 15 different defects, and that's much needed. So accuracy is extremely high. And there's simply no manual analysis needed anymore.
Would you say that that's like the most critical element in the value chain to improve that quality level in the deployment of the site?
Yeah, I mean, I think mass analysis of data and on-the-fly analysis is the major trend, but there are other things to implement to get to the right result, and they're not all technology driven. I'll give you an example on how not to do it. So let's go again back to your 150 megawatt project. Let's say you have a very good friend at a tier one, and you place your order with that factory, and they're going to take 6 weeks to produce your order. And you've signed a purchase order, but just a standard contract from the factory, basically. And at the last moment, you think, maybe I should do quality assurance, because I want to know what I'm buying, right? So let's say you send us to the factory, and we come to the conclusion during those 6 weeks that there are 4,800 modules that need replacement. Now we will go to the factory and we'll show the data, and we'll say, well, these need replacement, right? But very quickly the factory will say, well, we haven't agreed to that in the contract, right? There's not even a quality standard in the contract, or if there's one in there, it's not in your favor. It's a very loose contract where the defects are not defined. This is very common, and to come to a good result and to buy the very best modules, and this doesn't only count for PV modules. This counts for inverters, this counts for transformers, it counts for battery energy storage. You need to optimize your procurement contract. It's key. If it's the only thing you do, then that's the thing to do first. And it means that you very clearly define quality standards, visual standards, EL standards. You very clearly define inspection procedures, and also a kind of legal language that, if certain defects are found, you have the right to replace them on the spot directly without paying a fine or anything. So it's all these additional annexes for in the contracts. You don't have to reinvent the wheel. We've been doing this for over a decade, right? So we can help with templates, but it's a key thing to get right. And if you do it right one time, you will benefit for years to have this in place with your suppliers.
Okay, well, Dricus, unfortunately, I've got my 150 megawatt project that I need to attend to. So can we do a few rapid fire questions at the end? Can we run through a few topics that we're really keen to address? So firstly, repowering. We're seeing potentially a need for repowering, unfortunately, before it was planned in some occasions. How do you think, how big a role is this going to play in the industry in the next few years?
Yeah, repowering is a very big deal, and we are already doing projects for many developers who are actually repowering older plants, and typically either there's something wrong, you upgrade the plant, or it's technology driven, and you're making your plant better, higher efficiency modules, or the biggest trend is adding battery energy storage to existing PV projects. So it's a very fast growing sector, and I think could be close to 8 or 10% of our inspection volume is actually for repowering plants.
Wow, that's remarkable volume. Dominic?
Right. Let me ask another question on the insurance companies. How do you see that change, and how do the insurance stakeholder group come into play when we talk about quality assurance?
Yeah, that's a very relevant question. Insurers have been in this industry, of course, as long as the industry exists. They've become much more data driven, and we work for several insurance companies. Munich Re is a long-term partner for ours, and what you see is that insurance companies are very serious about qualifying factories. So the most common insurance is warranty insurance nowadays, but it's not that every factory can just get warranty insurance. Right? They go through a very thorough process of auditing, especially the technical side of a factory, fully understanding the technology and their capabilities before they commit to backing up their warranties. And especially in this stage where technology is changing very quickly, it's like technology is moving like a staircase. In the PV industry, like you take one step, and at some point it's a stable step. Let's say it's mono-PERC, and it's a very reliable, predictable, almost boring technology, right? And boring is good. Boring is very good in the PV industry, but it doesn't stay boring very long, does it? I mean, then we have to invent a new cell technology, and we take the next step, staircase. Then we go to TOPCon N-type, and looking at a completely new cell architecture, and it's like a reliability reset, right? And there's all kind of unknowns that come up, and insurance companies, they love to have data on everything, right? So we play a role there. Another thing that comes to mind, one thing that always bothered me in the past was we're a testing company. We're doing quality assurance at the factories. And sometimes clients would ask us, look, you're doing the quality assurance. We know you're preventing a lot of defects, and that's appreciated. But if we get an issue in the field, what will you do? And we didn't have a clear answer to that. But I started researching this, and I realized there's not a single testing company in the industry that actually takes liability, right? And that's actually strange because, for instance, an EPC, they have all kind of liquidated damages. Is a plant underperforming, they'll pay liquidated damages. They don't meet their timelines, they will pay liquidated damages, right? But testing companies, they don't. And we started looking for a solution there, and we teamed up with Munich Re. Basically, what we developed is a product that we call the quality guarantee. Just to explain it in 10 seconds, it's basically what it means. We have our quality assurance framework, which we call zero risk solar, which is 100% inspections at the factory. When you're developing a project and the panels are quality checked, if a client then runs into issues in the field and which comes to a warranty claim, they can actually claim liquidated damages with Sinovoltaics. They can claim with us, which is a completely unique thing in the industry. That didn't exist before we started this. And because, we're Sinovoltaics, we've been around for well over a decade, but we're not Microsoft, right? So in order to give a real proper guarantee, we're backstopped by Munich Re. And in case a claim comes up, a real warranty claim, the liquidated damages payout is automatic. And what this does, it means that if a client of ours has a problem, we have a problem, right? So now we have skin in the game. And this is the way we approach it, because we're thinking very long term. And our mission is to just exclude all the defects that we can possibly exclude. So that's one way that insurance company Munich Re is highly innovative, I would say, in the quality assurance space.
Well, okay, you've spoken a little bit about supplier risk and also technology risk. Of course, there's weather risks as well, and we are seeing a changing climate. We are seeing severe weather events become more common. Do you think there's an opportunity in terms of working with insurers as a PV project developer and also component supplier to kind of demonstrate that the risk of weather is being handled and is being taken into account throughout the project development lifecycle?
Yeah, it's a very good point. And I think everyone agrees that extreme weather events are becoming bit more common, and it is a challenge for the industry. If you zoom in on one particular thing, hail impact. I think hail is one of the major extreme weather events. I read somewhere it actually, in terms of claims, it's probably less than 5% of the number of claims. But in terms of claim value, it's well over 60%. So it's a very costly thing. So if your 150 megawatt project is hit by a severe hailstorm, it's probably a total loss. Like everything will have to be replaced, right? And of course, there are insurance products for this. But at first, I always like to look at how to prevent problems, there are some solutions I've seen. For instance, you have tracker companies that have early warning systems built in. That if a hailstorm is approaching, they move the modules in a certain angle so that the impact of the hail is minimized by about 90%. And so there are some clever ways to prevent the damage. Very simple thing is not to build projects in an area where hail is expected. I mean, it's of course a no-brainer, but I've heard from not from insurance companies, but firsthand from developers that there are areas for instance, in Texas, specific areas where insurance companies have quietly withdrawn from the market. So they simply don't want to cover it because there's too much risk. I think the manufacturers, they also have a role to play, and they could play a more important role. I mean, the current trend is still very much focused on cost reduction. So module designs that we see now, they're building bigger and bigger PV modules, right? Looking at a 650 watt, 2.4 meter long module, which is almost like 8 feet. Wafers getting larger and thinner, M10, G12 wafers. We call this the big floppy module problem, right? And what you see in the field with these very large modules, mechanical or stresses in general, they're proportionate to the size of the modules, but the rigidity is not. So the larger you make a module, the more these stresses like wind load have an impact. And what you see now is with large modules, you see breakages in the field. You see delamination, which was pretty much gone, and it's back, right? And when you go back to Hill, because these larger modules, they're getting so heavy, so they've been actually reducing the glass thickness to keep them somehow reasonable in terms of weight. So they went from 3.2 to 2 millimeters to 1.6. So they're not designed to withstand a hailstorm, right? They're not the heaviest design, and insurance companies know this. So if you're in a hail-prone area, it could be that you save some money on using very large modules. Then it will be completely offset because you're going to pay a higher premium, right? Because you're using these larger modules. So I'm afraid I don't have a solution for it, but it's certainly an interesting challenge to solve.
Well, and we are in an innovative industry, at least, so hopefully we'll see some more innovative solutions come up. We've actually spoken a little bit about the segmentation of the market in other episodes, which could be an interesting development going forward. Dricus de Rooij, thank you so much for joining our episode today, joining PV Unplugged, the CEO of Sinovoltaics. It's been a great pleasure to have you a part of the program.
My pleasure. Thank you.
Thank you, Dricus.
And thank you, Dominic Bürgi, the head of services for Stäubli, for co-hosting this episode, and also to our other guests, Joerg Althaus and Madeleine Hill. In episode 4 of PV Unplugged, coming up, we'll be looking into digitization and smart O&M with Govinda Upadhyay, the CEO of Smart Helio. Dominic will be joining me for that episode as co-host, and also Jyoti Jain, the head of software product management at NextPower. Thank you for watching this episode and for joining us. My name's Jonathan Gifford, and thanks for joining PV Unplugged.